Hello everyone. Today we're gonna just do the basic level of binary search. I just need to go over how to do this correctly and in the most efficient way possible because it is a good algorithm. So I learned this in not grade, first year, and I just want to recap and just go over because I haven't done any tree problems yet. I've just done array problems, but this is a good one for trees as well. So binary search for my explanation is just like for my example, if you have a group of books and you want to search through all, I think it would take a long time to actually go step by step to go through all, and it will take a lot of runtime and space. So what you would do for binary search is that you take the midpoint. If it's not in that side, you shift the left um, one, and if it's on the right side, then so you can find the actual book that you're searching for. So it's a good algorithm. So for this question particularly, we're just searching for the target. So if the nums at the midpoint would be the target, you just return the target. But if it's not the target, you have to keep on going left and right and finding it where it's supposed to be. So I'm gonna look back and watch this video so I can understand the explanations because this should be a basic algorithm that anyone should implement. So I'm trying to be like that. So the first step is the base case, and it's always if nums dot length. If it actually is nothing, if it's zero, we just want. In this case, we return -1 because that would be um like out of bound. Like that's what we want to return. And for the variables we have to initiate is left and start at 0 and start right at the end. Nums dot length -1. And for here, we're gonna check left is less or equal to right. Just so it's checking until the right, like until each index. And we always want to set a mid, and we'll say left. This is what I also learned before. Is right minus left. And you want to divide by 2 for all binary searches. It's divide by 2 because you're splitting it into 2. And then from this one already, we got to check if nums at mid, if that index is actually the target. If it is, return the actual mid. And yeah, so else if, so we want to say if it's nums at mid is greater than the target. So if it's greater than the target, we know that we got to just be like, oh, hold on, take a step back. So right equals mid -1. So we got to take a step back and be like, yo, it's less than, we got to go back. That's how I think of it. And then else, if it's greater, if it's less than, we got to come up, you know what I'm saying? So left equals mid +1. And I think this is very useful because let me comment this at target return target. So like I know take step back. Push up. And at the end, if it's not anything, then we just return -1. So yeah, I think this is a very good algorithm. This is the most basic implementation of it. So yeah, I think I understand it. I think if I was asked how to do this, it would be good. So yeah, it's the solution.